All right, welcome to this video for Introduction to Programming on Software Development. So, when you want to develop software, the most important thing is that you need to understand what it is you're going to be doing. You have to understand the problem. What is the problem? Am I going to do a program that's going to calculate by my income how long it would take for me to save $1 million, or that's going to calculate, take an input and translate it from metric to English? Or you have to decide, what is it that I'm going to do? Am I going to change the temperature from Fahrenheit to Celsius? So if that's the problem, what are the requirements? What do I need? What are the inputs? What is going to be provided for me in order for me to do what I need to do? And what is the order in which my calculations need to be done? And what is the end result going to be? Without understanding the problem, you are not going to be successful in developing a program. So that's what you need to do. Analyze it. What are the inputs? What are the outputs? Before you start sitting there and trying to write your code, make sure you understand the problem. Then you need to design the algorithm. So you need to start out with, okay, this is what I need to do. This is my big problem. And my big problem can be broken up into smaller pieces, and I can solve those smaller pieces much easier than trying to just solve this one big problem at once. So I'm going to give you an example with a turkey sandwich, where if you're going to make a turkey sandwich can be broken down to a whole bunch of small different tasks. Like, you can't just jump in and make a turkey sandwich. The turkey needs to be processed, the cheese needs to be processed, the bread needs to be made and baked. So whatever problem it is that you're trying to solve is made up of a bunch of little smaller problems or sub-problems, and that is what a top-down approach is. So then once you have specified the problems, you analyze the problems, you understand what you need to do, you have created this algorithm, which is just step by step. The way I like to say, there's a few ways to do the algorithm. One way is to make a flow chart, which we will cover later on in this class, or the other way is just to do step refinement. Like, number 1, greet the user. Number 2, get the input that I need. Number 3, make the calculation. Number 4, get the rest of the input that I need. Number 5, make the rest of it. So again, you need to understand, and decisions need to be made, and you need to be made if different paths have to be done, that's done with conditions. If things are repeated, that's done with loops. And all of this, you need to step back and think about it in order to be successful in writing and implementing your algorithm. And then, of course, once you have created your program, you need to test it and make sure it works. Now, in this class, I want to teach you how to test while you're implementing the algorithm. Don't just say, oh, you know what, I want to play this letter guessing game, so here's everything. No, I will give you step-by-step instructions. We will start by understanding the problem. We will then break it into the algorithm, and then we will break the algorithm into steps, and we will test along the way. That is very important to become a successful programmer. And then after you have created your program, obviously if you've created some software that's being used, then there are updates and things that need to be added to your software. All right, so what is abstraction? Abstraction is where you take the problem and you extract all of the essential information and the relationships between all of the data and the information, and you get a really good understanding of how everything relates. And an algorithm is a list of steps. Just like I said, I always start with step 1, greet the user, because that's the first thing you want to do in a program, is say, welcome to my program, or whatever. But number 1, greet the user. Number 2, get your input. Number 3, etc., like that. All right, so top-down design, like I said before, is just to break a big problem into sub-problems. So like my example of a turkey sandwich. So you have a turkey sandwich. Obviously, this is not a very successful turkey sandwich. It would be very hard to eat this. But a turkey sandwich is made up of maybe bread, lettuce, cheese, turkey, of course. And those are all subproblems. Like it's a subproblem that the cheese needs to be pasteurized and made, but that is a cheese can be used in your turkey sandwich, and cheese can also be used in a different kind of sandwich, a salami sandwich or something else. So the concept of these subproblems is what we're going to be learning about, which is functions, and those are things that are little pieces of work that can be reused. So a turkey sandwich, if you think about it, is made up of a bunch of subproblems, a bunch of different things that need to be done. The turkey needs to be processed, the bread needs to be baked and sliced, the cheese needs to be processed, the lettuce needs to be picked, and all of these things and all of these ingredients, these are the inputs to your turkey sandwich. So there's two things I'm covering here. One is understanding what we're inputting into it and understanding that our inputs potentially need to be processed as well. So we have our turkey, which needs to be processed into turkey, our bread, which needs to be sliced, our tomatoes possibly, or vegetables that we want to put on our sandwich. Maybe we want to put a mayonnaise or something on our sandwich, some cheese on our sandwich that needs to be processed and cut. So all of these inputs need to be put together. Now, some of these inputs need to be done in a particular order. For example, you want to put the bread on the bottom and the bread on the top and the other items in between. You might have OCD and have a particular order in which you need to put all of your items for your sandwich. But at any rate, some things, it doesn't matter what order. You put your bread on the bottom and the bread on the top, and your vegetables and all of the other things are just randomly placed inside of your sandwich. So the inputs, our turkey sandwich is made up of sub-problems, and those sub-problems then become inputs to our turkey sandwich. One more input, maybe some lettuce. So again, there is a way to combine the different inputs, and there are some sequential steps that need to be made. Like I said before, you need to slice the cheese before you put it on the sandwich. At least most people like to have their sandwich with sliced cheese. Once you're done, you have an output. So just like before, if I said you were going to maybe take Fahrenheit and change it into Celsius, or if you're going to take all of my salary or someone's salary and how much they make and how much their expenses are and how much their interest rate on their savings account is, and try to figure out if it's possible how long it would take to save $1 million. All of your inputs would be the money, would be the salary, would be the bank, would be the interest rates, would be all of these inputs, and then in the end you would have the result. Like here we have a turkey sandwich, you would have the result of the number of years it takes to become a millionaire. So all of these different concepts come into play when you are doing a program. There's one big problem that's broken up into subproblems, and then you can concentrate on the subproblems, and the subproblems most likely have an order as well. And then you have a bunch of inputs that need to be combined, and in the end you will have an output. So the biggest thing is that you need to specify the requirements, analyze the problem, design the algorithm, and make sure that you are understanding the order in which things happen. Then you can start to implement step by step. Do not try to implement everything at one time. And test and verify and maintain doesn't really apply for this class because we are just making small programs but you might make something cool that you want to update and maintain later on. So here's some other things about programming. These are some terms about errors in programming. So debugging means that you take your program and you go through it and you find errors and you remove them. So we will learn how to find ways to catch our errors in our program. The next term is syntax errors. If you looked at the last video, the code or source code is written in a text file, and the first step of the compiler is to compile that code. And when the compiler goes through that code, it checks for rules that are not followed in the language C. And these are things that The newer compilers like Visual Studio has little red squiggly lines and stuff to help you to find these syntax errors, and but the compiler might find them. But there are errors that the compiler might not find, and those could be caused by one of two things. A logic error, and that's the kind of error that means that you did things in the wrong order, like you tried to put the cheese on the bread without slicing it, or things were not done in the correct order. That's a logic error. A runtime error is something that happens while your program is executing, and it causes your program to usually to crash or problems to happen. So those are just the different types of errors. You will not be tested on these terms, but they are important terms to understand. And one more thing that I want to bring up is that some students, when you are doing your assignments in this class, every single assignment this class is independent work. It's really not possible to learn how to code by working as a group. It's like if you write an essay, you need to write your own essay. When you write code, you need to write your own code. And turning in someone else's code is plagiarism. So be sure that when you are working in this class, that you are doing your own work and you are getting assistance from all of the assistance that is provided by our college, university, and department.